Thanks for joining me again. Today we're going to take a look at multiplying decimals. Now we've already done addition and we've done subtraction. Those are pretty easy. We just had to make sure we wrote them vertically, lined up the decimals, did the operation, whether it was addition or subtraction, and then dropped the decimals straight down, and that was our answer. Multiplying decimals is a little bit different, and I'm going to show you exactly what I mean. Unlike with addition and subtraction, you do not need to line up the decimals when multiplying. So that's a good thing. If you're struggling with that, that's nice about multiplying is you don't have to worry about lining up decimals. So that's kind of a step that you don't have to worry about with this. But on the other hand, instead of lining up the decimal and dropping it straight down at the end, now after you multiply, there should be the same number of decimal places in the answer as the total number of decimal places in the problem. I know that's kind of a lot, and we're going to take a look at some examples, and I'll show you what that means. But when you get an answer to a multiplication problem with decimals, there should be the same number of decimal places in your answer as the total number of decimal places in both numbers from the problem. So let's take a look at what I mean by that here. First example, we've got 6 and 2/10, and we're going to multiply by a whole number to start with. We're multiplying by the whole number 7. I don't have to line up my decimal. That's a nice thing. If I did have a decimal on this 7, it would be right here. But again, there's no need to line it up, so we don't even have to worry about it. Let's go ahead and do the multiplication. If we take 7 times 2, we get 14. Bring our 1 up there. And 7 times 6, we've got is 42, plus 1 more gives us 45. Now, we used to just drop the decimal down when we were looking at addition and subtraction, but it doesn't work that way because our decimals aren't lined up. What we have to do is we have to include the same number of decimal places in the answer as the total number of decimal places in the problem. So let's take a look at what I mean by that. Up here you'll see that there's a 2 behind the decimal. That's 1 decimal place behind that number. Down here at the 7, there's nothing here. This is an empty space. So we don't even have to worry about that. So in my problem, there is 1 place behind the decimal. When I go down to my answer, I need to make sure I have 1 place behind the decimal as well. So I'm starting at the right, and I'm just going to go ahead and say, underline the 4, so I can say there's 1 place behind the decimal. If that 4 would be behind the decimal, that means that my decimal should go right here, giving me an answer of 45 and 4/10. Now, a good way to do this, and we looked at this in the addition as well, but a good way to do this is just to think about simple estimation. If I forget about any decimals in this problem, I know that 6 times 7 is 42. So my answer should be fairly close to 42. If for some reason my decimal is between the 4 and the 5, giving me an answer of 4 and 54/100ths, 4 is not anywhere as close to 42. I would know that I'm way off. If I put my decimal at the very end, giving me 454, again, that's not close to 42, so that's giving me a number that's way off. Doing that type of front-end estimation, just kind of deciding based on the whole numbers what the answer might be, isn't going to give you the exact answer, but it's at least going to tell you if you have your decimal point in the right place. Let's take a look at a little bit more difficult one. Let's add another decimal into it. Now I've got 1 and 46/100ths, and instead of just having a whole number, I'm going to actually have another decimal here. Again, we do not need to line up the decimals, so I can do this. So go ahead and work my problem. 5 times 6 is 30. Bring my 3 up there. 5 times 4 is 20, plus that 3 gives me 23. 5 times 1 is 5, plus 2, 7. All right, now, anytime that we go to a second number, meaning we move over to this second location, the tens place, or in this case it looks like the ones place, we need to make sure that we include a 0 right off the bat. Then we can do our multiplication. Now some of you might already see something that we can do here, or maybe that we don't have to do. Some of you might be looking at this saying, oh, if 0 is multiplied by all these numbers, all I'm going to get down there is zeros. That's right, you don't have to actually do this step. But if you did, it would look like this. 0 times 6 is 0, 0 times 4 is 0, and 0 times 1 is 0. And we would just be adding all those numbers up. But instead of doing that, we can just go ahead and skip that 0 because it takes one step out of what we're doing here. And it makes it just a little bit quicker and easier for us. Take a look up at the problem. In the first number, there's 1 2 digits behind the decimal point. In the second part of the problem, there is 1 number behind the decimal point, giving us a total of 1, 2, 3 places behind the decimal. We have to have the total number in our answer. So this would be 1 place, 2 place, 3 places behind the decimal, meaning our decimal needs to go right there. Now, I won't count it wrong if you just leave it as is, but I like to go ahead and put a 0 in there just to kind of keep the place value and make it look a little bit nicer. Again, you don't have to, but it's just something I like to do when I'm working these problems. This is the big difference between adding and subtracting. You have to have the same number of decimal places in your answer as you had total in the problem up above. Let's look at one more example, and then I'm going to turn you loose to try some on your own. Bigger decimals here. We've got 2 and 24 thousandths. We're going to go ahead and multiply by 1 and 35 hundredths. Remember, no need to line up the decimal. We can just go ahead and do the multiplication. 5 times 4 is 20. 5 times 2 is 10 plus 2 is 12. 5 times 0 is 0 plus 1 is 1. And 5 times 2 is 10. Remember, we're moving over to this 3, so we need to put a 0. 3 times 4 is 12. 3 times 2 is 6, plus 1 more is 7. 3 times 0 is 0, and 3 times 2 is 6. 2 more zeros because we moved ourselves now over to this 1. 1 times 4 is 4. 1 times 2 is 2. 1 times 0 is 0, and 1 times 2 again is 2. Last step here would be to do all the addition before we go ahead and put our decimal place in. So I'm going to add all these numbers up. A row full of zeros gives me 0. 2 plus 2 plus 0 is 4. 7 plus 4 plus 1 gives me a total of 12. Carry the 1 over. 2 plus 0 plus 0 plus 1 gives me 3. 1 plus 6 plus 0 is 7. And 2 plus nothing up there gives me a 2. Lots of numbers down there. We need to make sure we get our decimal in the correct place. Looking up at our problem, there's 1 number, 2 numbers, 3 numbers behind the decimal place in the first part, and 1, 2 numbers behind the decimal in the second part, giving me a total of 5 digits behind the decimal. Going down to my answer, I have 1, 2, 3, 4, and 5. 5 places behind the decimal. My decimal belongs right there, giving me an answer of 2 and 7,324 ten-thousandths. All right, I'm going to turn you loose. I want you to try some now. As always, when you're ready, pause the video, work the problem out, and push play to see the answer. Go ahead and give it a shot. Let's see how you did. 8 and 4 tenths. We're multiplying by the whole number 3. Your problem should look like this when you set it up, so we can do our multiplication. Hopefully you took 3 times 4 and got 12. Bring the 1 over. 3 times 8 is 24, plus 1 more gives us 25. So we have 252 down there, but we need to make sure we know where to put our decimal. There is 1 digit after the decimal up there, none in the second number, so that tells us I have to have 1 place behind the decimal there for an answer of 25 and 2 tenths. How'd you do? If you got it, great. Move on to the next example and try it on your own. If not, rewind the video, take a look at how I did it, look at your work, and see where your mistake was. Your turn number 2. We've got 1 and 3 tenths times 4 tenths. Go ahead and pause the video and push play when you're ready to see. All right, 1 and 3 tenths times 4 tenths. If we do our multiplication, 4 times 3 is 12. 4 times 1 is 4, plus 1 more is 5. Now, you might have worked out the 0 and did 0 times 3 is 0, 0 times 1 is 0. But remember, like I said earlier, anytime you see a 0 all the way over there at the very left-hand side, there's no need to do it because all it is just adding an extra step that really doesn't change the outcome. So right now we've got a 5 and a 2 down there. We need to figure out exactly where that decimal goes. There's one decimal place after the decimal in the top. There's one digit in the decimal places after the decimal in the second number, so we end up with 2. 1, 2 place values after the decimal, so we need to have 1, 2 in our answer. Our decimal belongs there. We can put a 0 in front for an answer of 52 hundredths. If you thought that you were wrong because every time you do a multiplication problem your number gets bigger, like 2 times 5 is 10, 3 times 4 is 12, those numbers always get bigger. But when you work with decimals, that's not always the case. That's not always the case. So just because you got a number that's smaller than what you started with doesn't mean you did it wrong. One last example. Try one more on your own here. Push pause, work the problem, and push play when you're ready to see the answer. All right. 5 and 12 hundredths. I'm multiplying it by 23 hundredths. You did the math correctly. 3 times 2 is 6. 3 times 1 is 3. And 3 times 5 is 15. Since you're moving over, you put the 0 there, go to the 2 and start multiplying from the 2. 2 times 2 is 4. 2 times 1 is 2. And 2 times 5 is 10. Let's add. 6, 7, 7, 1, 1. Last part, figure out where to put the decimal. 2 spots in that one. 2 spots in that one, giving us a total of 4 decimal places. 1, 2, 3, 4. Your decimal should go between the 2 ones there. 1 and 1,776 ten-thousandths. Remember, as always, you can come in before school and see me, after school and see me for some help if you need it. Otherwise, hopefully you guys learned something today. Thanks.